So we're going to take a look at this. This is a matching problem, number 16 from Investigation 3. But before we do this, if you're having troubles and you haven't graphed the equations from the Investigation 3.3, now is the time to pause the video and use your graphing calculator app on your phone or a internet-based graphing calculator to graph the equations that we used today in class, which were n squared, n times n minus 1, and n times n minus 1 divided by 2. So if you have not graphed these yet, obviously you should do that now so that you can do the homework better. If you've already done that, you're still looking for explanation, here you go. So first description, which graph represents the equation for the number of high fives exchanged? Well, that's just straight out of our investigation. And so our equation from our investigation was here. Now I'm not going to go into how we derived it because that's what we did in class. So the first thing, really the only thing you need to do, is find the x-intercepts. What would make that n 0? Well, 0. I substitute in n for 0. What about here? What could I substitute in to make this whole parenthesis 0? Well, 1 minus 1 is 0, so my two x-intercepts are 0 and 1. And so we can go through and we can eliminate all graphs that do not have x-intercepts of 0 and 1. Nope, nope, nope. That's a 0 and negative 1. So therefore, A is going to match with 2. B, which graph might represent the equation for the areas of a rectangle with a fixed perimeter? Now those were the first graphs that we did, and we've done tons of them. And you should remember that as the area approaches a square, or as the shape approaches a square, the area for that fixed perimeter increases. And then once you're after the square, the area decreases. That's straight out of here. So once here's my square, and at my square, that's when the area decreases. Or 3. Which graph represent the equation for the areas of a rectangle formed by increasing the dimension of a square by 2 centimeters and decreasing the other by 3 centimeters? Well, I know the answer is C. Sorry, I know the answer is 1. And I know that because we are getting an area of, there's my square, and I've increased it by 2 and decreased one dimension by 3. So my x-intercepts, using that method again, what's going to make this 0? Well, negative 2 plus 2 is 0. Over here, 3 minus 3 is 0. So which graph has x-intercepts of negative 2 and 3? That would be this one here. So we have graph 1. Obviously this is going to be 4, but the triangular numbers, remember, was 1. This is your n value, and this is the number. So 3, 6, and 10. You realize that that is incredibly close to the this situation with the high fives. In the high fives, we had 0, 1, 3, 6, 10. Well, lo and behold, it has a very similar equation, which would be n times n plus 1 over 2, which would make the x-intercepts 0 and negative 1. Therefore, it matches that one.